Hi everyone, welcome to my channel Code with Ease by Varsha. We are doing a series on solid principle. Today we are going to discuss about the first principle, that is the S in solid, which is single responsibility principle. First we are going to see in layman terms a very common analogy of what each of this principle will mean in subsequent videos. So today we'll talk of single responsibility principle, and after that we'll see the official definition of what that each principle is trying to mean, and we'll see a code example to correlate with a real world scenario. So we can see a couple of kitchen tools that is hanging. So now we know that every tool in the kitchen is designed for a specific purpose. If we see the fourth tool, this is for picking up something which is liquidy in nature. In India, we have something lentils or dal. Can you try to lift rotis or breads using this? You cannot. You cannot use this particular tool for doing that. Similarly, the third one is actually used for lifting the rotis or the breads. It works as a tongs. We call this tongs. So this third tool has a specific single responsibility, and the fourth one is having a specific different responsibility. So that is what this principle is trying to say. Let each of your tool or each of your class or each of your module in the software deal with one responsibility only, and let it not mix up. We cannot use those tools interchangeably for different types of responsibilities in the kitchen. Okay, so now let's move to the official definition, what it says. So the official documentation of single responsibility principle states that class should have only one reason to change. Class, again, why? Because we are talking in terms of object-oriented paradigm. We'll talk of classes and objects every time. Now, every class that we write, now you can think of a class in Java, or maybe you can think of any module in a software system. It doesn't matter. So any discrete module in a software system, let's talk of in that way, it should have only one reason to change, which means that if you are doing one thing, do it properly, do it well, and only do that. Don't try to mix things up. Like we were seeing in our analogy of the kitchen tools. If one tool is designed for a specific purpose, what is going to happen when you're going to use that tool for something else for which it is not designed to do? Like we were saying that example of the ladle, which is used for serving liquids. Now, if you try to use that in some other place where it is dealing with solid, will you be able to do that? So what happens in software systems is if a class, again a module, has multiple responsibilities, it becomes prone to bugs or errors because you have no clue which responsibility is causing that issue. Number one. Second is it's also very hard to maintain and hard to test. And obviously, if hard to maintain and hard to test, there will be more bugs in it. So if a class is designed to do something, you do that only well in a proper, you do that responsibility, you take care of your responsibility and do it well. So if we can see, there is one example of a file manager class. File manager, a simple class which deals with files. All of us have dealt with file systems at some point in another. Three very common things that we do. We read a file, given a file path, we try to write to a file, we write some content into a file and we write it into a file path, and log. Log is just for logging a message. So there are three different responsibilities we can see in this class, which in the first glance or first look, it looks fine that, okay, there is a file manager class, it is reading a file, it is writing a file, it is printing the loggers. So what's the issue in this? It's a file manager class. It can do anything and everything related to the files. But the problem over here can be, but this example is violating the SRP, the single responsibility principle, because the class, if it has to deal with read file, I have not written the code of reading the file, but it will be a little bit complex code. So if it is having the responsibility of reading the file, it should only do that. If it is having the responsibility of writing to the file, it should only do that. And similarly for log. Why do you want to mix up the responsibility? Because when I'm reading file, I only need file path, whereas when I'm writing to the file, I need a file path and a content also. So you see, there is a clear definition of responsibility problem over here. How can we refactor this code? Let's take a look. So I have applied SRP to this and I have segregated the responsibilities. I have created separate classes. So this is what SRP is trying to highlight. Whenever you see more than one unrelated responsibilities in a class, separate it out. File reader. So that is why if you have worked with files in Java system, you might see there are reader classes, there are writer classes, right? Because reader classes means it is only going to do with the file reading, because file reading is not only going to be read file. There can be so many different modifications of the read file system only. Just for reading the file also there can be different methods. So why do you want to bloat up your code by writing code which is not related to reading the file? So keep it separate now. File data reader, so keep it separately in a different class. Anything related to reading of the file, you keep it in that class. Anything related to writing of the file, you keep it in file writer class. And logger, we know logger in itself is a different class in Java. But just for the sake of example, we are going to show that we also have a separate class for logger, because logger cannot be only just log and write log message. There can be different variants of the logs. So that is what is trying to be highlighted in this code example, where we have earlier violated the SRP and now we have fixed it by trying to put it different classes with single responsibility each of them. So thank you so much for watching. See you guys in the next video on the open close principle.